right. Hi, Phil. So good of you to sit down with us again. A lot of good progress has been made at Smoltek, and I'm very excited to have this discussion with you.
Yeah, hi Louise. It's good to be here with you.
So I'm just going to dive right in. The ultra thin capacitor market is advancing, and we no longer just hear about TSMC and their relationship with Apple, but also other players such as Murata, who have just expanded their scope of their silicon capacitor offering by opening a new production line in France, and Samsung, who are actually this year starting to mass produce silicon capacitors in the fourth quarter of 2024. So based on this information, how do you perceive the ultra-thin capacitor market evolving this past year, and what do you believe are the main drivers?
Yeah, so I think the main drivers are still application processors for mobile phones, where space is at a premium, but we're definitely starting to see a push toward applying these type of capacitors for power delivery in AI server applications.
What are your thoughts on how the technology adoption will develop based on the increased availability through these new initiatives?
Yeah, so first, let me make a comment on Murata and Samsung. So they're both technology leaders in the MLCC market,
Mm, yeah,
substantial market share and, have the most advanced technology so that they've invested in silicon capacitors. I mean, to me, that's really a indication that they believe that there are limitations in multi-layer ceramic capacitors that can be overcome by silicon capacitor
mm,
technology. So I believe that the silicon capacitor, the technology will be used in applications where MLCC solutions just can't meet the technical requirements. So initially, the silicon capacitors will be a higher cost solution, and engineers will only design them in where they absolutely have to. But I believe that as volume ramps up, the costs will come down, and that will allow silicon caps to be used in more and more applications.
What applications do you think will lead the way? Is it handheld devices, or are there other applications that where this will start?
Yeah, already started in handheld devices, and then they'll be used, I believe, in other portable and wearable devices like watches and like that, things like that, where space is at a premium.
Hmm.
But as I mentioned, the other potential market where we're starting to see at least some offerings are for these AI applications for AI
Yeah.
processors. And the issue there is that the power for these processors, especially the GPUs, is very high. So we're talking about 1,000 watts potentially for the next generation,
Mm,
which means for a 1 volt or less processor, that's 1,000 amps peak. So
yeah.
every ohmic drop in the system makes a difference. So even a few millimeters away from the processor, you place the power delivery system, you have a tremendous resistive loss and tremendous, inefficiency there. So the thing about silicon caps, of course, is as we know, we can make them very thin, which means that they can be put into power delivery systems that are put right underneath the processor. That's called vertical power delivery, which then
Mm.
decreases the losses and increases the efficiencies.
Uh, but looking towards the future, if you look like 5 years ahead, how do you think the market's gonna look? Are we going thinner and thinner and thinner, or is it more power? Or what are we looking at for the
So,
ultra thin capacitor market?
right. So the other advantage of silicon capacitors, and specifically you mentioned power, is
Mm,
that with them being fabricated in a semiconductor fab, it's easy to put multiple terminations on them.
yeah,
So if you look at the ones, on the land side of the application processor, they have 6, 12, 18, something like that, balls on them that terminate on the processor, power pins, and the reason for that is low equivalent series inductance, which
yeah.
becomes very important, with these high speed, processors and high frequency decoupling. And I think, that's another advantage of the silicon capacitor is that you can do these multiple terminations in a semiconductor fab process much more easily than you can do with multi-layer ceramic capacitors,
Ah,
where you can put a few terminations on, but putting 18 or 20 solder balls and terminations on there would be very difficult.
yeah.
Mm-hmm.
But let's move on a little bit to Smoltek and kind of what we've been up to this past year since we talked last. How do you think that the Smoltek technology development has progressed this past year?
Yeah, so I've been following it, closely, close contact with Smoltek's CTO, and been getting, regular briefings. And there's really, been two big advancements. One is you've switched to a much higher dielectric constant stack. So from hafnium aluminum to this zirconium aluminum zirconium, and that gives about more than 1.5 times the increase in dielectric constant, which ultimately enables higher capacitance capacitors. And then the other big advancement is being able to grow better vertical nanofibers. Just to say, I've seen the scanning electron microscope photos, and they're very impressive of what the team has been able to do in the last year.
Yeah. And what do you think are our primary technological strengths?
So, I've always thought one of the strengths of Smoltek is that it's first that the carbon nanofiber technology is an additive technology as opposed to the subtractive technology, that Murata and the others in the industry use. So you're not etching holes, so you have potentially a better mechanically stable, substrate. I think another advantage, really looking into the future, is that carbon nanofibers can potentially be grown on a variety of substrates, so you're not limited to silicon. The other technology is, because it's a silicon etching technology, but you could potentially grow carbon nanofibers, let's say on glass or alumina. And as I think everybody knows, there's been a lot of press and interest in glass, interposer substrates out there. Intel and others are, committed to commercializing that. So looking to the future, potentially Smoltek technology could be applied to, some of those advanced substrates.
And if we just go back to the the capacitor technology that we're working on now, how do you see that we're standing and compared to the market?
Right. So, clearly the market leader, at least for what we understand, is out there is TSMC.
Yep.
And Smoltek's made good progress toward getting to where they are. So they're about 1.5 microfarads per square millimeter. Talking to Smoltek CTO, he hopes to release a product in early 2025 that gets about a third of the way there. And then later in 2025 or early 26, basically match what TSMC has. And that requires the ZAS stack is one enabler there. The better carbon nanofiber, vertical carbon nanofibers are another. And then the other key, the two other keys are getting those carbon nanofibers taller, so from about 4 microns to 10 microns, and then overcoming any challenges of depositing the ZAS dielectric material down into the depth, that 10 micron depth of nanofibers.
Yeah. What are your thoughts on the reliability of the technology so far?
Right. So we're testing the basic dielectric right now in our Yageo electrical testing labs, and we're seeing actually very stable performance under heat and voltage. So far, I think we've gotten to 500 hours or so of testing. Things are looking very stable. The Smoltek team worked with a academic lab in Korea to really optimize this dielectric stack, and it looks like that collaboration has really paid off.
And, we've talked about for the Gen 0 samples that came out, we've had issues with these direct current leakage. It's been an important, issue for us to solve. But now it seems like we're on a track to do so, and the team has really made progress in that area and understanding and solving the issue.
Yeah, I agree with that statement. Like I said, one of the parameters we're testing this dielectric for is leakage stability, and so far, the leakage stability is very good. So clearly, the team has overcome, some of the issues that they faced last year.
All right. So, just for my last question, how do you view the competitive landscape within these ultra thin capacitor market?
Yeah. So as I said, I think that Murata has, continued to invest in their, fab in France, going to the 200 millimeter process,
Mm,
and that Samsung, who of course is not only in the component part of the electronic industry, but the overall electronic industry, is an absolute giant. So I don't think those two companies would be investing in the silicon technology unless they saw that there was really a market for it.
yeah.
So I think, so there's pluses and minuses. So the pluses, that two giants in the electronics and passive component industry are investing in a technology that's similar to Smoltek. Of course, the minuses is that they're pretty fierce competitors, right?
Yeah.
And
Yeah.
they're both world class companies, in addition to, of course, TSMC, another world class company. So Smoltek definitely has its work cut out for it. But I think, the advantages is that you have a unique technology that's different
Mm.
than the technology that they've invested in, and that has the potentially to exceed, the performance of the incumbent technology once it's fully developed. So I have optimism that that will happen, and we'll see Smoltek, product that not only equals what's out there today, but also, is able to surpass it.
Well, thank you so much, Phil. It was great to sit and chat with you again.
Yeah, thank you, Louise.